Chapter 7 Study Guide. For number 1, which of the following does not represent the sides of a right triangle? We could use Pythagorean Theorem to determine which ones are right triangles and then decide which one is not. So a squared plus b squared equals c squared. So let's go ahead and substitute in letter A. 9 squared plus 12 squared, we're going to see if it equals 15 squared. 81 plus 144, and 15 squared is 225. 81 plus 144 does add up to 225. So A is a right triangle. We're determining which one is not. So let's try B. So let's do 3 squared plus 4 squared to see if that equals 5 squared. 9 plus 16, does that equal 25? 9 plus 16 is 25. So B is a right triangle. Let's try C. 8 squared plus 15 squared. We're going to see if that equals 17 squared. So 64 plus 225. Does that equal 289? So let me add 64 plus 225. And that does add up to 289. Whoops. So that is a yes. That's a right triangle. So it must be letter D, but let's check it. 5 squared plus 6 squared. Does it equal 8 squared? 25 plus 36. Does that add up to 64? Nope, it adds up to 61. So letter D is not a right triangle. A 15-foot ladder rests against a wall. The bottom of the ladder is 9 feet from the base of the wall. Approximately how high up does the top of the ladder reach? So we're going to show the work and the formula. A picture might help too. So if I sketch a ladder that's 9 feet from the wall, and the ladder is 15 feet, I'm going to see how high up it reaches. I see that this makes a right triangle. So the formula we use is a squared plus b squared equals c squared. Now let's sub in our values. I would say I don't know what a is. I'll use 9 as one of the legs, and the ladder will be the hypotenuse. So a squared plus 81 equals 225. Here's a one-step equation. To isolate the variable, I'm going to subtract both sides by 81. And 225, take away 81 is 144. Then the final step would be to take the square root to get a by itself. Square root of 144 is 12. So we got to make sure that's reasonable. The ladder would reach up 12 feet. We're going to find the value of x in each of the following diagrams. So here is x, but that is part of the larger triangle. So it looks like I'll have to use the smaller triangle first, and I do have the legs. So a squared plus b squared equals c squared. So I'm going to use 3 and 4. 3 squared plus 4 squared is c squared. So 9 and 16 is c squared. The final step would be to take the square root. So in my picture right here, that would be a 5. Now you can see there's tick marks there that show that these two pieces are even, so that's 5 and 5. So the hypotenuse here to here would be 10. So now I have a leg and a hypotenuse to figure out the value of x. So I have to do another problem. So I have 6 squared and I have the hypotenuse of 10. So let's finish this one off and subtract. So I get a squared is 64, then the square root of that is 8. So a is 8. So in my picture, that would be 8. So that was a multi-step problem there. For question 4, it appears to be a hemisphere, and inside the hemisphere we're looking for the hypotenuse in this right angle. Now since this is a hemisphere, we know the whole way across is 10, so half of this would be 5. The distance from the center to the edge all around the hemisphere would be 5. So both legs are 5. Let's use Pythagorean theorem to figure this out. So I'm going to substitute the legs 5 squared plus 5 squared equals c squared, and then continue to solve. 25 and 25 is 50 for c squared, and our last step is to take the square root. So it's an irrational number. If I round it to the tenths place, the 7 would make this go up to approximately 7.1 for our hypotenuse. Number 5 is a cone, but we're looking for the value of the x. It looks like we're looking for that radius, and I do see that this is a right triangle. So to get this value, we could use Pythagorean theorem. The 6 would be the hypotenuse. So a squared plus 5 squared equals 6 squared. A squared plus 25 equals 36. And then we would have to subtract to get a squared by itself. And that would give us 11. Then the final step would be to take the square root of 11. This would be an irrational number. We would get about 3.316, If we round to the tenths place, that would be to here, we would get approximately 3.3. For question 6, we're going to find the value of x. I can see that this is a big right triangle inside a little right triangle. So I would want to find this leg first. So I will use a squared plus the leg of 12 squared equals the hypotenuse of 20 squared. 12 squared is 144 and 20 squared is 400. This is now a one-step equation, so I will subtract 144 on both sides. that gives me a squared, which is 256. Then to get a, I take the square root of 256, so a is 16. So this value right here, the whole leg, is 16. So you see these marks here? That means those are the same length. So that would mean if the whole line is 16, then one of these would be 8. Same thing goes with this side. The double pair, those mean those are also the same, but it shows it with 2 marks. So if the whole line is 20, then half of this right here is 10. So now in the smaller triangle, I'm missing a leg, but I do have the other leg and the hypotenuse. So we have to do a squared plus b squared equals c squared again. So a squared plus the leg of 8 squared equals 10 squared. And that is 64 equals 100. Then subtract 64 on both sides to get a squared by itself. That would equal 36. Then the final step would be to get the square root of 36, which equals 6. So the value of x, this leg here, is 6. So for my final answer, x equals 6 centimeters.